Okay. Rick, the presentation is now yours.
All right. Thank you, Mike, and thank you, everyone, for signing up for the Lesman webinar. Hopefully this will be an interesting few minutes for you, and we'll talk mainly about a product that United Electric Controls designed going back to 1998, and we're now in the third generation of that product. It's what we call the 1 series, and it's an electronic pressure or temperature switch. Can everybody hear me okay? Great.
Yes.
Okay. So the agenda looks like this. I have about 28, 29 slides. We'll talk about what the 1 series is, how does it compare to mechanical switches, the features and benefits of using an electronic switch over both mechanical switches and also process transmitters. Why does United Electric call it the 2-wire? Easy, cost-effective plant upgrades, if something like that you might be interested in. The cost of failure, the cost of when an instrument fails to operate as planned. We'll also look at comparing the 1 series to a typical process transmitter. And then at any time, as Mike mentioned, please interject with any questions that you might have. The 1 series is an electronic pressure or temperature switch. So we have various sensors available for gauge pressure, differential pressure, and we also measure temperature with this device. It's available in a Div 1 package, which you're looking at on the left side of your screen. Kind of looks like a transmitter. And on the right-hand side, that's a Division 2 model. Both are electrically identical, but as you can see, packaged quite differently for various hazardous location needs. The 1 series is all solid state. Therefore, it has no moving parts, and that provides a unique advantage, particularly when you compare it with a mechanical switch. Consider, for example, an application where you might have a high cycle rate. On a mechanical switch product, that high cycle rate would cause the switch to have a shorter lifespan, whereas with the electronic switch, it really doesn't matter how often it switches. Also, consider vibration, shock and vibration, how that can affect a mechanical product versus the 1 series, again, with no moving parts. It really has little or no effect whatsoever. There's a digital display included, so you could say that the 1 series is not only a switch, but it's a gauge as well. And, of course, if you consider potential leak paths for whatever the media is that you're measuring, this could be an advantage. And finally, and I probably should have put this bullet first, but we have a fully adjustable set point and deadband. And again, unlike a mechanical switch, which has a somewhat adjustable set point and typically a fixed deadband, with the 1 series it's programmable. So you set both of those wherever you want over the range of the sensor. And if you think about that just for a second, you realize how many applications that opens up for a device like this where a mechanical switch just would not be suitable. So let's look at set point and deadband just graphically here, just to make sure everybody understands. So if you look at this diagram that I have, we have a normally closed switch, and as the pressure begins to rise and it hits the set point, the switch opens. Pressure continues to rise, then perhaps it decays, begins to fall, hits the deadband setting, dB1, and then it resets or closes. Some people refer to that as the hysteresis of the switch. We call it deadband, but realize that both of these points are fully adjustable over the range of the sensor. And then just flipping this upside down by literally changing a setting in the 1 series, we can have it act on falling pressure. So just like before, we might have a normally closed switch that opens as the pressure falls and hits the set point, and then resets or closes again when the pressure rises back up and hits the deadband setting. Pretty simple concept. So let's compare now the 1 series to a typical mechanical switch, whether it's United Electric's mechanical switch or some of our competitors. They all work on a similar principle. They both measure pressure or temperature, both have a set point and deadband settings, and both are used to initiate an alarm or a shutdown. And if we take a look at some of the moving parts in a typical mechanical switch, as we apply pressure to the diaphragm, which may impinge on a bellows, again depending on the design of the switch, you'll notice that the You'll notice that the snap acting switch eventually makes its way from a normally closed state over to a normally open state. Now all of these parts are physically moving in order to do that, and over time and temperature changes and humidity and vibration and so forth, that can have an effect on these moving parts. The 1 series electronic switch has no moving parts. Therefore, when we apply pressure to the diaphragm, that acts on a oil fill, which is transmitting the pressure to a strain gauge. The microprocessor reads the change in resistance across that strain gauge and instructs the transistor to open or close at the appropriate time. And again, nothing physically moves. It's a transistor switching on and off. So again, comparing the two technologies, we have mechanical switches which are considered blind devices. Blind in the sense that if they stopped working, if they encountered a fault of some sort, there's no way for that device to tell the operator, tell the control room that the switch is no longer functional. It has moving parts. I think we've beat that one to death. And it may or may not be adjustable, again, depending on the design and the manufacturer of the switch. The deadband may be fixed or somewhat adjustable, but there could be a fixed range of adjustability to deal with. In the 1 series, you have a fully self-diagnostic device. This is what United Electric calls the I am working feature. And if you're familiar with the device, you've seen that on the display. There's a little indication that the product has completed its initialization and self-checking, and everything is working fine. And it continues to do that throughout the operational life of the product, so that if any problem were encountered, it's able to detect that and to report it. And we'll get into how it does that in just a minute. Again, the 1 series is all solid state. It has no moving parts, and it's 100% programmable set point and deadband. Comparing the two technologies, and I have to apologize at this point because I'm beating mechanical switches up pretty severely here, but I'm doing it to make a point. And also I should add that United Electric Controls manufactures many different types of mechanical switches, and it is the major portion of our business still today. However, we think we've got a better mousetrap, and so we sometimes compete with ourselves with this 1 series device. So I think you can understand where I'm coming from. So the 1 series again is solid state. It's no moving parts. The mechanical switch has various types of sensors and actuation abilities for a typical micro switch, all of which are moving parts. The 1 series has I am working self-diagnostics. Mechanical switches are blind. There's no way for the mechanical switch to report its health status. The 1 series has a digital display, so it's a gauge and a switch. A typical mechanical switch has no display capability, although some of UE's mechanical switches do have dials on them. We have a programmable deadband. If you consider adjusting a mechanical switch, and if you're familiar with the process, you realize that you need some tools. You typically need to remove the mechanical switch from the process and bring it to an instrument shop. You might need some calibration equipment and a lot of patience, and perhaps 2 or 3 iterations before you get that mechanical switch readjusted back to its factory settings, versus the 1 Series, which is fully programmable, and with 2 buttons I can do all of those things. There is a version, or I should say a few versions of the 1 Series that includes a 4 to 20 milliamp output. So you could consider that one device a switch and a gauge and a transmitter all in one. And usually mechanical switches are switch only. And then let's talk about accuracy and, I think more important, repeatability. The 1 Series is a 0.5% accurate switch, which, simple translation, if I've got a 100 psi sensor, my range is 100 psi, I'm within 0.5% of 100 over the entire range of the sensor. So if I enter, for example, a set point of 50, I can expect the 1 Series to switch at 49.5 to 50.5 or somewhere in between. And the repeatability number means that wherever it does happen to switch, it's going to hit that mark within 0.1%, which is extremely accurate switching, as you can imagine. And it will do that over a wide temperature range. Temperature range being 0 Celsius to about 70 degrees Celsius. We guarantee the accuracy and the repeatability. So again, if you've got switches currently in service that are drifting due to changes in weather, this would be an ideal solution to that particular issue. Finally, the 1 Series electronics are encapsulated in epoxy, which gives UE some protection over the circuitry that's involved inside the epoxy encapsulation. So it's kind of protects our electronic design, if you will, but also provides effective barriers from any sort of moisture getting in, and also from shock and vibration. Any questions before we move on? Okay, let's look at this 1 Series self-diagnostic capability, what we call the I am working feature. And that diagram on the right is kind of a what you might see on the display as the product is operating. It's similar to that. I did my best to draw it. But what exactly are we looking at with the self-diagnostic capability of the 1 Series? Well, first and foremost, it's doing a checksum error on the software. You might consider switches that are mounted outside, and perhaps last night we had a lightning storm, and perhaps the lightning struck the instrument. Well, you know, it's going to do its best to continue working. However, it has detected that part of the software was damaged by the lightning strike. Although it appears to be working, there's a checksum error, and the 1 Series will alert us to that fact. We could cause damage to the keypad, for example, by striking it with a wrench. And you might say, well, my goodness, you know, maintenance people would never do such a thing, when in fact, that's how mechanical switches are often tested. To trip the switch, they'll whack it with a wrench to cause the micro switch to change state and make sure that that signal is making its way all the way back to the control room. And it's a very crude test, but nevertheless, that's what happens. And if the 1 Series got damaged by somebody doing that, it would know it, and it would report it. Also, an overrange condition on the sensor, underrange condition, the power supply itself being out of range, the sensor being clogged. If you have impulse lines that are clogged, the 1 Series knows about that and can report it. The sensor itself, is it open, is it shorted? The switch, same, it can detect that. And finally, there's a watchdog timer. And this timer is expecting certain things to happen at certain times during a cycle of the software inside the 1 Series, and if it doesn't happen when it was designed to, the 1 Series will report that type of error called watchdog. Let's look at area classifications here for a second. The 1 Series is suitable for harsh and hazardous locations or applications. Due to its solid-state digital design, it's excellent at resisting shock and vibration and wear and tear. The adjustable deadband allows it to act as a single-loop control. Consider, if you will, a typical pump. You might have a single-loop controller controlling that pump. The 1 Series is perfectly capable of controlling the start and the stop cycles of that pump as well, by virtue of its adjustable set point, where you might start the pump, and the adjustable deadband where you would stop the pump, and the fact that those 2 points are 100% programmable, and they're accurate within 0.5% and repeatable within 0.1%, you've got an ideal single-loop control for a typical pump or compressor, for example. Digital display allows the 1 Series to replace both a switch and a gauge, reducing the leak paths. The programmability really provides an easy installation and setup. It takes about a minute, literally, to go through 4 steps to set your set point and your deadband and your switch mode, and then save your settings, and you're basically finished. The self-diagnostic capability really increases the reliability of the product and the maintenance department's peace of mind. Is this product going to work when I need it to? I haven't had a chance to get out there and check it in the past 3 months because we're short on manpower. Will the 1 Series do the job for me? And if it's not reporting any errors, then yes, it will. Again, you've got the 0.5% accuracy and 0.1% repeatability, providing you with a very precise switch action. And then finally, it's a fully temperature compensated device as well, giving you an effective operating range of 0 to 70 degrees C with full calibration, and then the instrument will go all the way down to minus 40 degrees F and up to 185 degrees F without any effect on the instrument whatsoever. It still continues to operate. The accuracy and repeatability may suffer outside or below 0 Celsius or above 70 Celsius, but still continues to operate. So the burning question is, how old are your mechanical switches that you currently have installed at the plant? And you see here there are many different mechanical switch manufacturers around the world. Some of these we're familiar with, and others perhaps sold only in Europe or in Asia, and we haven't really heard of them. But there are several, and this is by no means a complete list, but it does represent our major competitors at United Electric. If you consider all of those manufacturers and the number of mechanical switches currently installed that are about 10 years or older in age, you're looking at about 4 million. That's our best estimate. And these are the NEMA 4, NEMA 4X, or explosion-proof type switches I'm talking about, similar to our 120 series, for example. And 75 to 80% of that 4 million that are 10 years or older are connected to a PLC or a DCS input, meaning that they're not handling high current, although they're capable of 5 amps or 10 amps, and in some cases 15 and 20 amps. They're simply switching milliamps to the input of a PLC or a DCS. So we took that notion and we've designed a 1 series that can do exactly that. It can connect to the PLC or the DCS input with a simple 2-wire connection and obtain a small amount of leakage current to power the 1 series, and in return provide a discrete on-off switch-like signal back to that same input over the same existing 2-wire connection that was previously used for the mechanical switch. So that makes for a very easy and cost-effective instrumentation upgrade. If you're considering replacing mechanical switches at the plant, you may be looking at transmitters as a replacement. I urge you to consider the 1 series as a better means of upgrading the plant, more cost-effective, perhaps easier, and very definitely less expensive. Here's why. If you consider the self-diagnostic capability that we have covered in the 1 series, process transmitters are typically limited in that regard. They have the live 0 4 to 20 milliamp signal that they can encode certain error codes on, but what exactly are they looking at, how do they report it, and how that information is picked up in the control room needs to be considered. The response time of the instrument, a lot of people aren't aware of this, but a typical process transmitter that's running HART protocol can take 300 milliseconds or more to react to an upset process. And in some applications, who cares? You know, that we're not that critical on time. But on other applications, especially where safety is concerned, safety of plant instruments and processes, and also the people that are in the area, then the response time becomes critical, and it must be considered whenever mechanical switches are being removed. And I should add here, since I've been beating mechanical switches up so much, that the response time on a typical mechanical switch is 5 milliseconds. So it is the fastest reacting device that is currently available, and you should keep that in mind as well. The local display on the 1 series is included in the price. On some transmitters it's optional, and on others it's not even available. The plug port detection, again, is included in the 1 series, optional or not available on some process transmitters. The 1 series is, in fact, a switch. It's primarily a switch that can provide a 4 to 20 milliamp output, but we have designed this as primarily a switching device. Process transmitters do not switch. You can program your PLC to provide the switch, but that comes at a cost, which we're getting to. The local programmability, as I indicated to you, takes about a minute. Process transmitter, you have to program the PLC or the DCS to have that transmitter look like a switch by detecting certain pressure or temperature levels, where the 1 series has the switch built into it. And we have versions of the 1 series which are powered externally using 24 volts or 110 volts, and those are capable of handling current in the form of amps, up to 10 amps, in fact, and those make ideal for local switch applications where the transmitter really requires it to be connected to a PLC or DCS in order to provide that switch function. So when you get to the bottom line and you consider the cost of not only the instruments themselves, but all of these other things required to make the transmitter look and act as if it's a switch, then you're looking at roughly 2 times the installed cost. And I've been told that that's conservative, but for the sake of argument, let's call it basically you're paying double per point to install a process transmitter in a typical switching application. Setting up the 1 series, so let's say we've just installed this, connected it to the pipe, we've connected the 2 wires to it, the display lights up, so now what do? I press both buttons to get into the edit window and where I can set the switch mode, and the switch mode is literally, do I want the switch to open or to close at the set point, and do I want it to act on rising or falling media, pressure or temperature. Next, we set the set point, and again, that's anywhere over the range of the sensor with 0.5% accuracy and 0.1% repeatability. And then the deadband, the reset point of the switch, again, is fully programmable, and I can set that anywhere over the sensor's range. It takes about a minute to go through these 3 steps and then to save the settings. I should mention here, if you're wondering about tamper resistance, tampering with the instrument, inadvertently changing the set point, what we have done is we've designed an instrument which is what we'll call tamper resistant. I don't think anything is tamper proof, and in fact an instrument with its password written on the wall next to it is definitely not tamper proof. But we did not implement a password of any kind, any sort of a code. Instead, we have this tamper resistant feature, which basically allows you to get in very easily, start changing some of the programmability here, the switch mode, set point, and the deadband. But if you don't take the next steps, the instrument automatically times out and discards any changes that you've made and continues to work with the previously saved settings. In order to save the settings after you've gone through these 3 steps, you need to hit both buttons simultaneously. It defaults to a no setting. You have to change that to yes, and then press both buttons again to deliberately change these 3 settings, which, as you are quite aware, can be critical settings in a typical plant environment. So that's the way we've answered that question. I'm not sure what this device is. I kind of grabbed this picture off of the internet one day as I was putting some slides together. But it does tell a story. You see the technician with a feeler gauge and a screwdriver, and he's adjusting the gap on something, perhaps a set of points on a combustion engine or something. But I think you get the point here. Removing the mechanical switch, taking it to the instrument shop, making the adjustments with tools, testing it with a calibration device, and then reinstalling it. It all takes time, and then it leaves a hole in the pipe while you're making these adjustments. Wouldn't it be better if you had a device that you could adjust and calibrate while it's in place? And that's exactly what the 1 series is. So getting back to that question, why does UE refer to the 1 series as the 2-wire? And I've given you a few hints already. But mechanical switches don't require any power whatsoever. They are typically 2-wire devices. And as we learned earlier, about 75 to 80% of the switches currently in service are 2-wire devices connected to a PLC or a DCS input. Some 1 series models don't require power either. We use a very small amount of leakage current derived from the 2-wire connection to the input. And that's how it works. So even though it's an electronic device, there are no batteries inside it. It takes its power from the input of the PLC in the form of leakage current. And we've patented patented this two-wire electronic design that we developed here at UE, and it is, in fact, unique to the 1 Series. You won't find any other electronic switches on the market today that can operate like this. And I'm sure you're wondering how it does it, and we're going to get to that in a second. But let me just ease your mind by saying, if you're familiar with a proximity switch and kind of the two-wire concept with a prox switch, it is pretty much the same concept that we use with the 1 Series. And why is this important? Why having a two-wire switch? Why is that important? Well, first and foremost, if you're upgrading your plant and you've got mechanical switches connected to PLCs or DCS inputs, then you don't have to bear the cost of pulling additional wiring. That's all taken care of by virtue of the 1 Series being able to operate using that leakage current. So let's take a look now at how it does it. In order to do that, I'm just going to briefly compare it with a mechanical switch again. So my ladder logic diagram here shows a very simple circuit. It's a mechanical switch connected to the PLC digital input or discrete input. It's a 24-volt input, and as you can see, if I actuate the switch, I activate the PLC input. If I open the switch, we deactivate the PLC input. It's a pretty simple concept. Note down below, when my mechanical switch contact is open, current flow is absolutely 0. And when I activate the input, it's approximately 2 milliamps for sake of argument. It could be slightly more, slightly less, and that's all determined by the resistor that's in series with the input. That's part of the PLC input. That series impedance or resistance, whatever you want to call it, determines the current flow when the mechanical switch closes. Now let's upgrade to the 1 Series electronic switch. We have the same two-wire connection to the same PLC discrete input. Note, however, that although my 1 Series switch contact is shown in its open state there, that a small amount of current is leaking past it, shown by that little red box below the switch. That's a resistor. It's not really what's in the 1 Series circuit, but just to illustrate for you what's happening here, that current flow of approximately 500 microamps flows around the 1 Series open switch, and in the process of doing that provides enough power to run the 1 Series electronics and the digital display and the self-diagnostics and so on. And of course, when I close the 1 Series switch, I activate the PLC input. The same current flow of approximately 2 milliamps flows through the closed 1 Series switch. And just to illustrate again, when it's open, very small amount of current is flowing through there, not enough to activate the input. And then when I close the switch, we have more than enough current flowing through the 1 Series to activate the input. So that's kind of the two-wire concept. Again, similar to what you would find in a typical proximity switch circuit. So, how many switches do you store in your storeroom for when events occur? In other words, when that mechanical switch stops working and it's beyond repair, or you just don't have the time to adjust it, you want to put another one in its place as quickly as possible to get things up and running again. The 1 Series can actually simplify your inventory. One range can handle many different applications. Let's take, for example, in a typical plant, let's say pressure never ever exceeds 1,000 psi. I could choose the 1 Series with a range of 1,000 and satisfy many applications that don't nearly get that high because of the programmable set point and deadband and the accuracy and repeatability that I have. We have both Div 1 and Div 2 models available, but you could, for example, purchase all Div 1 models and satisfy the needs of both Div 1 and Div 2 areas. So there's no mistake possible when the maintenance person runs to the shelf to grab a switch. He couldn't possibly grab one that's limited to Div 2 because he grabbed one that can play in both Div 1 and Div 2 areas. The units of measure are field adjustable. This was just announced yesterday. And this is a new version of the 1 Series that allows you to change from degrees F to degrees C, for example, or from PSI to bar to kilograms per centimeter squared, and so on and so forth. And there are many units, engineering units to choose from, and it's very easy to do. The 420 milliamp versions of the 1 Series include a 2-to-1 turn-down capability. Not nearly as great as a typical process transmitter, but nevertheless, you could have the 4-to-20 milliamp signal cover only 50% of the sensor's range, for example, if you chose to do that. And it has that capability. And you have adjustable offset and span. This is a feature that the 1 Series has that really isn't required in most cases. There are a few instances where perhaps the diaphragm has been damaged because somebody was cleaning it and used a sharp instrument and put a nick in the diaphragm. Well, that device is now damaged. It's not going to read 0 at 0 pressure. What can we do about that? Well, we can adjust the offset and span in the field and effectively recalibrate the instrument. How does that work? Well, quite simply, you would block and bleed the 1 Series so that it's absolutely receiving 0 pressure. When you're sure of that, you look at your display. Is it reading 0, yes or no? If it is, you're finished. It's calibrated. If it isn't, then you would check the diaphragm. Is it damaged? And use the offset and span to recalibrate it. Another reason for providing offset and span, actually there are 2. One is you might want the digital display on the 1 Series to exactly match the digital display of another instrument, and you can essentially force it to match the other instrument by taking it out of calibration using offset and span, taking it out of factory calibration. And the other is if you've added a chemical seal to the instrument that has a very long capillary, and let's say the seal is up high with respect to the instrument itself. You've got the weight of all of that fluid impinging on a sensor that can be as low as 0 to 5 psi. You have to account for the weight of that fluid. Offset and span allows you to do that. And again, you can do this while the instrument is installed and on the pipe and in service. You don't have to remove it, and you don't need any special tools. Let's take a look at some applications for the 1 Series. Where is it typically used? Water and wastewater treatment plants is a very popular application for the 1 Series. As I mentioned to you earlier, they're ideal for controlling pumps and compressors. They're showing up a lot in power plants now, where you have fewer and fewer people available to provide maintenance. You need instrumentation that will act on its own, do the job, and if a fault occurs, be able to report it. Automobile assembly plants, oil and gas pipeline, compressor stations, petrochemical refineries, oil heaters. Those are just a few of the many applications that the 1 Series is used on. Water and waste treatment plants, it's typically controlling a pump. And just to give you a view of one plant that I know of located in Washington, D.C., the Blue Plains upgrade project was taking a very old wastewater treatment plant and bringing it up to current standards, and there's approximately 125 1 series installed at this plant, and most of those are controlling pumps. I've mentioned to you the 1 series having the switch gauge and transmitter functionality included in it. You're all familiar with this Christmas tree arrangement. Here's a way to reduce the number of leak paths from a minimum of 12 down to 2, reduce the process dead leg issue of the media getting trapped within the piping, reduce the cost of the instruments themselves, reduce the labor to create that Christmas tree and then maintain it after it gets clogged up. And in the deal, you get an increase in your system reliability by having a fully self-diagnostic instrument providing you with the switch gauge and transmitter function all in one. The 1 series, we nicknamed it internally the pump switch. None of our marketing materials will state that, but it does hint at one of the #1 applications for the 1 series, and that is controlling pumps in many different types of applications and industries. This particular one, you may have heard of the damage that Hurricane Katrina caused down in New Orleans. The Army Corps of Engineers designed a pumping system that uses the 1 series to monitor lubrication oil pressure and temperature and provide an emergency shutdown for the Caterpillar diesel engine that you see in the picture and down at the bottom. And this is multiplied by 21. So there are 21 of these pumps at strategic locations on the canals that crisscross New Orleans. So if the pump gets activated, they can move tremendous amounts of water in a very short amount of time. In a power plant application, here we have a typical lube oil application. We also have combustion permissive and filter monitoring, replacing a bunch of different mechanical devices, some of which you can see in the photo. I should note that I mentioned to you earlier the 1 series is approximately 12 years old now. Here's a 12-year-old design still functioning in the application at the top of the photo there. And then as you move down to about the middle of the photo, you see 2 of the newer 2-wire versions of the 1 series, what we call the Generation 3 product, also in operation at the same plant. So this guy is a very early adopter of the 1 series technology. At Honda Manufacturing in Marysville, Ohio, they use the 1 series to control their hydraulic presses. These are physically very large machines that stamp out hoods and fenders and doors for the Honda Accord to the tune of about 1,800 cars per day. So needless to say, throughput is extremely important in this application. Nevertheless, you've got an extremely harsh environment here. You could imagine when the 2 tools come together to stamp out the side of a Honda Accord, for example, you've got extremely high shock and vibration. You've got atomized oil in the atmosphere that will get into any instrument, including the 1 series, but because we're epoxy encapsulated, that's not an issue. You've got a water hammer effect. When those 2 tools come together, the hydraulic oil pressure backs up through the lines and wants to upset all of the instrumentation that's connected to that line. The 1 series has a nuisance strip filter built into it that you can activate and basically slow down the response time of the instrument because it was not a real event. It was simply a water hammer issue. So it's a good solution for Honda, and they've got several hundred of these in their Marysville, Ohio plant. Some other applications, which I'm hinting at here, we produce these application success stories, which are on our website, which is www.ueonline.com. And you can find these application successes there. And they talk about a real-world application, some of the issues associated with that application, and the solution that the 1 Series provides. And again, this is just a handful here. You can take a look for yourself and read these. And at this point, I'd like to open it up to any questions that you might have. I realize we've covered a lot of material in about 45 minutes. But if you have any questions, I'd be happy to entertain them.
This is Chris. I had a question. You'd mentioned on your last slide a nuisance filter or a nuisance trip filter.
Yes.
So that's built. Is that built into it? And if so, how long of a delay is that you can have on it?
Yes, it is built in, and it's deactivated when we ship the product. But it's simply a couple of keystrokes to turn it on, and you can set the time constant to. You have 4 choices. It's a quarter, a half, 1, and 2 seconds.
Okay,
so
great.
You're basically setting up that adjustable window of time using that. Any other questions?
If there are no more questions, Rick, I'd like to thank you for your presentation.
Sure.
If anybody does have any specific application questions, you can feel free to give us a call at 800-9-LESMAN. I'm going to take the presentation back. All right, you can see I put our number up there so that if you do have any questions, you can easily jot our number down. If you don't know who your salesman is that covers your account, feel free to ask for me, and I'll make sure you get taken care of. In the next week or so, we'll send you an invitation to join our LinkedIn forum. It's a way of keeping you up to date on upcoming webinars, as well as place or post your questions and connect with others that have attended seminars. When we do post a new session, LinkedIn is the place that we post it first, so give it a try. If there are no further questions, at this point our presentation will conclude. And thank you very much for attending.
Thank you.
Great. Thanks.
Thank you, Mike.
All right. Thank you, Rick.
Okay, sure thing.